Hey guys, I just wanted to give you guys a walkthrough of the assignment for today and tomorrow. I do want to let you guys know that I will be out until Friday, so I will see you guys back on Friday. Once I am back, remember all this stuff is due, and I do expect you guys to get this done. Uh, if you need help, I'll be glad to jump into Google Meet with you and help you out. So when I get back, you guys are all set and ready to go. All right. So follow along with me now. Part A, I do want to point out part A and B are going to be due today, which is the 25th. So by the end of the 25th, and then part C will be due by the end of the 26th. So follow along with me, and I'll do part A now and B. Okay. So first you want to do, go in here, all right, and open up the mastering balancing equations folder, and then click on the the balancing equations challenge. Now, something I do want to point out to you here, and it's really important you see this, you need to open this in Kami. Use Kami to open the assignment below. If you don't do this, you won't understand this assignment and you won't be able to edit and mark on it like I want you to. If you have Kami installed on your computer already, you will see this stuff down here. So see where my mouse is? Right here. You'll see this open the assignment with Kami, and you click on that, and that's how you start the assignment. If you do not see this right here, click this link. It will take you to the Google Store, and it's the link to download Kami for your browser. You're going to need to refresh your screen after it downloads and finishes, and then you should see this button again. If you do not see this button and you tried this, let me know, and I will get in a Google Meet with you and make sure I can get it installed on your computer. But it's very important that you have this, otherwise this lesson will not make sense. All right, so once you have it open, you can click here, and this is what you should see. All right, so I'm doing this on a demo sheet, so it's this is not gonna look like you should have a turn in button up in the corner, and I'll get to that later. But see, I said part A and B are due on the 25th, and part C is due on the 26th. So I'm gonna be walking you through part A and B now. So first up, part A is up here. All right, so it says circle each subscript in the chemical formulas, draw a square around each coefficient, and answer the question about the element below. So what you need to do is just that. So down here at the bottom, you have a shapes function. So you have rectangles and circles. So it says circle the subscript. So I'm going to start with, let's do this H1 over here. So, all right, because it has a little bit of both, and it'll make it easy for, make it easy for me to demonstrate what you need to do. So first it says circle each subscript. So I'm going to choose a circle. I'm going to take my mouse and come over here and create a circle around the subscript, just like that. So the subscripts are the small numbers at the bottom. Next, draw a square around each coefficient. Coefficient are the numbers that come in front of the symbol. So I'm going to click on square. I'm going to change my color so it's a little bit easier to see. Let's go with blue. And I'm going to create a square right above it. Click and drag until I have all the number 5 inside the box. So I followed instructions for step 1 and step 2. And now I just need to answer the question below. So the question is, how many atoms of hydrogen are shown in this formula? So what we need to remember are the coefficients and the subscripts. The coefficients tell you how many groups of the following atom there are. So it's saying that there are 5 groups of H2. So in order to get the total number of atoms, you multiply the coefficient times the subscript. So my coefficient in this situation is 5, and my subscript is 2. 5 times 2 is 10. So what I'm going to do is I'm going to put 10 in that box below by clicking on the text box here. All right, and select my color. I'm going to come over, I'm going to click on the box where I want the text to go, and I'm going to type in 10, right? If you would like to move it, all right, all you got to do is click on this move thing, and you can move it around. If you want to resize your text, if I highlight it, I can go up to the top, and I can select a smaller font so it fits in the box a little bit better. I think 16 works pretty good. And then I can drag it to fit there. If it's not directly on the line, that's okay. All right, so I understand like sometimes it might be a little bit confusing or hard to get it directly there. As long as it's somewhere near this one right here, you're good to go. So that's how you do number one. All right, so I'll go through the next one as well. Hopefully that will make this easy for you. So the number two, or this one right here, I'm gonna be doing with the CH. So for the CH, I'm going to put a circle around the put a circle around the subscripts. So I'm gonna go back up to shapes, choose circle, and the subscripts here are 2 and 6. The circle there, oops, and a circle here. If you would like to move them or change them around, you have to go up to, like I want to make these a little bit more central. So I'm going to click on select, and then I should be able to move. I thought I would be able to, there you go. You can move the circles around a little bit. All right. If you mess them up like I just did, all right, I'm gonna click on the eraser, and then I'm just gonna come through and erase and then try again. I would like my circles to be a little bit more over the actual numbers I want. There we go. That's better. And then it said put a square around the coefficient. The coefficient's the big number in front, like that. All right, next, I'm going to how many atoms are there of each. So remember, the coefficient times the subscript will tell you the number of atoms. The subscript behind the number tells you how many symbols there are in front of it. So it says there's 2 carbons, 2 C's. 2 times 2 makes 4. So I'm going to click on this box here. I'm going to type in 4. And I realize that my thing is out of whack. All right, and then again, you can move that around so it fits. All right, H is 6. I have 6 H's, and I have 2 groups of 6 H's, so that makes 6 times 2, which is 12. All right, and that's how you do part A. All right, should be pretty straightforward. Part B down here, you're just going to be using the text box function. All right, I'm going to use a different color. So I need the products, reactants, subscripts, coefficient, and yields. So you just identified the subscripts and coefficients up here with squares and boxes. So if you want to place those things, you got to click on the box that points to that. Okay, so for example, the subscripts are the little numbers. So in this box here is the one that points to a subscript. So you click here and type in subscript. Like that. And then I want you to go around and place the other ones. I know we haven't talked about the word yields technically, all right, but if you place all the other ones, the only empty box is the correct answer for yields. All right, when you're done with this, you're done for today. I want to keep it light, keep it easy. Make sure you guys have stuff that is attainable to get done in one day. And then tomorrow, we'll work on part C. All right, so you can stop the video now at the end of day 1, and I'll be back tomorrow for part C. If you're feeling like you can, go ahead and give it a try. All right, if you want to go ahead and test your luck, go for it. And then I'll be back tomorrow to help you with that. And that's all I want today. Do not hit the turn in button up in the top corner. Okay, do not hit the turn in button. All right, I want you to turn it in tomorrow after we're all done with this. All right, if you have any questions, let me know. Hey guys, this is part 2 to help walk you through part C. So this is the assignment that you should be doing on Wednesday, January 26th. Remember, I will be back on Friday and we'll be turning all this stuff in today. So remember to start, we did parts A and B on the 25th, and we're doing part C on the 26th. So this is part C. So for this, what I want you to do is remember what you saw in that Edpuzzle assignment, the 5 steps to balancing an equation. That will help you out greatly with this part of the assignment. Also, this stuff up here is training for these problems down here. So you're going to need to know the coefficients, what they mean, and you need to definitely pay attention to the subscripts and what they mean. I'm going to be using the words products and reactants a lot, so that also assumes that you know what this part is up here. All right, so for this, I am going to be going over, let's see, and mark this up. We're doing question 1 here. We'll be doing question 2 here. And I'll come down and I'll, this one looks big and nasty, so I'll try this one here. So the ones that I'm highlighting are the ones I'm going to review with you. The ones in between are the ones that I expect you to do alone. So I expect you to do 1, 2, 3, 4, 5, 6, 7 questions on your own. All right. Now remember, I'm going to be looking more so for attempt on here. If you get them right, that's great, but I want to see actual effort. No matter whether you get the coefficients right or not, I absolutely expect you to count everything. No matter whether you understand what to do or not, counting is half the battle. I do want to point out that the parts right here, I'm going to change my color. So this right here, all right. So on each one, you should see a T, all right. And this is called the T chart, like everything that I'm highlighting in blue, all right. All this is a way to help you count and keep track of the amount of symbols on each side of the equation. So remember, I told you that I want you to take the chemistry out, and I want you to treat this like a number game. You can come back to the chemistry later, but this T chart is not some magical thing that will transform the chemistry. It's just an organizer to keep you organized and organize the amount of each element on each side of the equation. That's the only thing that these T charts are for, okay? Because you could technically do this in your head, but we're not there yet, so I want you to get good at it, doing it like this. So to start with this first equation here, using the text box is the way to go here. I've seen students try to write it on the screen using the drawing, and that's going to be really tedious for you. So let's just do the text box and go ahead from here. All right, so you can start by listing the atoms, counting the atoms, and then solve. So again, the list and count is something I expect everybody to do no matter what. We can do the solve part together because that's where the skill comes in. All right, so step 1, you're going to count the atoms on each side of the equation by listing them out. So I'm going to click here, start my text box. I'm going to list H. I'm going to list O. All right, so remember I told you that they're always going to have the same atoms on each side. So the symbols will be the same on both sides, but the amount of each symbol will be different. So I'm going to encourage you to go ahead over to the other side and go ahead and just paste those in. That way they line up nicely, and that's half the battle too, is just organizing. So step 1 is complete. Step 2, count. All right, so here I see that I have a H2. I don't have a coefficient, but I do have a 2, which is a subscript. That tells me I have 2 hydrogens. Right? And I'm going to count the oxygens too. I have another subscript of a 2, so that tells me I have 2 oxygens. So I've counted everything on this side. The arrow comes next. This dividing line here helps you see that that's where you stop counting and you go over to the other side. So here I have H2, which tells me I have 2, which is bonded to an O, which does not have a subscript, so it's only a 1. This is half the battle. If you can do this, which I fully expect every student watching this video to do. So even if you don't know what to do next, this part right here where we count it out is crucial, important, and super easy. All you gotta do is count. Next step. You look for the mismatch, the ones where the numbers don't match, and then you start on the lower end to balance. So sometimes you'll have more than one that mismatches, and in that case, it's just kind of personal preference on where you start. Okay, so you can see the H's are equal to each other, so that's not where you start. The O's are not equal to each other, so that's where we start. And as you can see, this O here only has 1, and the other side has 2. So this O is where I start. So you have to ask yourself, how do you make 2 oxygens, or 2 O's, show up in the equation? By what coefficient would you have to add right here in order to make that happen? So in order to make 2 oxygens, you would need 2 groups of H2O. So 2, you can ask yourself, what do I have to multiply this number by here to equal this number? So 1 times 2 makes 2. So this 2 multiplies everything inside here by 2. So it's 2 times 2 hydrogens. Again, this box is only for counting. So this will now become a 4, and this will become a 2. So in the act of balancing out the oxygens, the O's, you have now created a mismatch in hydrogens, which is okay. That happens occasionally, and that's totally normal. So what you should be looking for is the fact that they are multiples of each other. If they are multiples of each other, your next step is super easy. If not, I'll show you what to do. So what you gotta do next is come back over to the lower side. For H, ask yourself, what times 2 equals 4? That's a simple answer. 2 times 2 makes 4. So up where I find the hydrogen, I have to put a coefficient of a 2 in front. 1. So that changes my counts down here. 2 times 2 makes 4. That has no effect on the oxygen because they're not bonded together. Therefore, you're all done. So 4 and 4, 2 and 2, this equation is complete and balanced. All right. Next up. This one. All right, so step 1. You got to do listing each element. So on this side, let me get rid of the highlight box because it's not going to let me light in there. All right, so on this side, I have an H, and I have an O. Like I said, feel free to go ahead and copy paste that over here because you will have the same letters, and I find it's easier to have them in the same order so they line up like that, but if you don't, it's okay. You just need to make sure you're matching the correct elements together. Next up, H. How many do I have? I see 2 on this side, so I'm going to put a 2 in. So it's a 2 from this right here. All right, O's, I have a subscript, but no coefficient, so that's also going to be a 2. I'm gonna go over to this side now. Next, I'm going to go with H's. So I see one H here. Or sorry, two there. So I'm gonna put a 2 here. All right, now this is a little tricky. This, remember that the T-charts only are supposed to help you count the total number of each symbol on that side of the equation. So where the drop-down bar is, to the right, all the H's, there's only 2, and all the O's. Now, a lot of students get confused at the part that you have 2 separate O's here that are bonded to different things. However, like I said, the whole point of this is to to show you the total number of oxygens on that side, because the law of conservation says the matter in a chemical reaction cannot be created, means it can't just appear out of nowhere, and it can't be destroyed, it can't just disappear. So this is the total number of oxygens on the product side of the equation, and you need it to equal the total number of oxygens on the reactant side of the equation. So I'm going to put a total of 3 because I have 2 here plus this 1. So a total of 3. So make sure you're looking out for that as you go through this assignment to make sure that there's only one place that that atom shows up. Any atom that shows up in more than one place, you have to count it all together. So for example, here is a good one. All right, again, you have oxygen showing up in 2 places. You have it with this CO2, and you have it with O2. So you're gonna have to add those together when you do your counts. All right, so when you see this happen, it's normally a good idea not to start there, okay? Because if you ask yourself what times 3 is 2, that doesn't work, and you have to find a common multiple. But then that means you have to mess with both places that the O shows up, which can get messy. So even though this is weird, and this is what I mean by like when we do Sudokus and you try different numbers and they don't work, and you go back and you mess with them and then you get them to work. This is what I'm talking about. So you got to play with this a little bit. All right, so you're gonna have to mess up something that's already balanced to make this work out. So what you want to think about is common multiples. When we did this over here, and you had the hydrogen set up like this, 4 and 2 are easy multiples of each other. It's easy for your brain to go, oh, 2 times 2 is 4. Or this number times this number easily makes the number on the other side. That's key here. So to add one more oxygen would make an easy multiple of 2 times 4. So oxygen only shows up once in H2O. So it'd be easy to add a 2 in front and add one more total oxygen to this side. So that's where we're going to start for this one. And I understand that this one's a little bit weird and outside the box to start with, but that's what we got to practice. So I'm going to add a 2 in front here. What that does is now it makes me recount everything. So H2 times 2 makes 4. So I have to change this to a 4 because now I have 4 total hydrogens. And 2 times 1 makes 2 plus the other 2 here. So that changes my total to 4. A lot of times students make the error of multiplying whatever is in the O's times what the coefficient I just put in, and that will create the wrong number, and that won't be good. So now I go back over to the other side. Thankfully, both of these are bonded together, and 2 and 2 easily go into 4. So I'd have to put a 2 in front over here, make 2 groups of these elements, which would make this 4 and this 4. And thankfully, everything is balanced after that point. Okay. All right, so like I said, that one was weird, and I need you to keep your mind open as we go through these because some of them are weird and a little bit confusing, to be honest. But I'm really looking for you guys to come through and put some brain power behind this and try. When I get back to class, I will be glad to help you work on this because all you need to do is practice, 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 practice. Okay. All right, so this is the last one I told you I'd do. I'm actually going to go ahead and let's look at this aluminum one too while I'm here, because I do want to show you about what happens when you don't have numbers that evenly go into each other. So I am going to be looking at this one as well. All right, so let's do this yellow one, this done here first. All right, so it looks ugly, but that's okay. All right, so stick to the program, stick to the plan. List out each element first. I see an A show up. I see an S show up. And I see an O show up. Okay, I also see CA. And then I see a CL. Oh, all right. That might feel like a lot. Now, as you get better at this, you can start shortening steps. Like you can go through and do all the counting in one step in the listing. But I understand that might not be doable right now. So again, like I said, I'm going to copy and I'm going to paste over here because everything will be the same on both sides. The symbols will, but the number of each symbol will be different. All right, let's go back and count. All right, NA. NA shows up 2 right here. So I'm going to put a 2 there. I have no coefficient, so that's all it's going to change. Yeah, this thing's annoying. All right, I have 1 S and 4 O's. 1 S, 4 O's. CA, no coefficient, no subscript, so just 1. Oops. And then for CL, I have a subscript of 2. So that means there's going to be 2 CLs here. So I'm done counting on the reactant side. I'm going to go over to the product. All right, so you can do this 2 ways. You can go from left to right and list, or you can go based on what it says in the box. So I'm going to do that just because it's a little bit easier. So I have 1 Na and 1 Cl because there's nothing bonded to it. There's no coefficient and there's no subscript, so I'm just going to have a 1. My S is still a 1. My O is still a 4. 1, 4. Ca, no subscript, no coefficient, so that's a 1. And like I said before, my chlorine is also a 1. All right, so start on the low end of any mismatch you see. So the things that are mismatched I see here is sodium and A. Sulfur is the same, oxygen is the same, calcium is the same, chlorine is different. All right, so it doesn't matter which one you start with. Both, no matter which one you start with, you're going to get the same answer. So I'm going to start with sodium. I'm going to start on the low side, which is the products over here. I see sodium show up, bonded to chlorine. So in order to get 1 to equal 2, I have to multiply 1 times, oh yeah, 2. So in order to get 2 sodiums or NAs produced, you have to multiply it by 2. So I'm going to put a coefficient of 2 in front. All right, so 2 times 1 makes 2. It also changes my chlorine because they're bonded together. So I have 2 groups of chlorine as well. Oh, hey, look at that. It just balanced everything for us. Okay, so that's what I'm saying. Like when you do some of this stuff, this one looks really ugly, but if you stick to the steps and go one by one, sometimes they balance out by itself. All right, so we did when we started the reaction, chlorine was also not balanced, but when we just tweaked sodium, it also changed chlorine to be balanced. So sometimes it just works out nicely like that, and a big ugly equation is as simple as putting a 2 in there. So as you can see, Na, S, O, Ca, and L are all equal now, and you're done. All you got to do is put in that 2, and you don't touch anything else. All right, lastly, I'm going to do this one really quick because I do want to talk about what happens when you don't have easy numbers that go into each other. All right, so I'm gonna fly through the counting and listing really quick because we've gone over that now 3 times. All right, so I have L, O, paste, 2 and 3, and over here I got 1 and 2. All right. So this one is tricky for a few reasons. It seems like there's an obvious start. All right, AL and AL. Okay, 1 times 2 is easily 2. All right, but even after you do that, all right, so even after I do this, and then change this to a 2, my 3's are still uneven. All right, so I got to work on them. So like I said, you start at the lower end of the mismatch. So you have 2 O's over here and 3. There is not a whole number that you can multiply 2 by so that it equals 3. So what you have to do now is find the lowest common multiple other than 1. Everyone always says 1, other than 1. So normally you just multiply the 2 numbers together and that's what you're shooting for. So 2 and 3 both have a multiple of 6. That's the lowest common multiple they have is 6. All right, so you have to make them agree and meet in the middle because they don't multiply into each other evenly. So O on the product side right here, I want it to have 6. So what I do is what number times 2 is 6? The answer is 3. So I'm going to put a coefficient of 3 in front. So 3 times 2 will change my total count on this side to 6. Finally, I have to go on this side and get this oxygen to agree and have 6 as well. It shows up bonded to this aluminum, so I have to make a coefficient of 2 in front of it so that I have 2 groups of 3 oxygens, which makes 6. Right, however, since aluminum and oxygen are bonded together, putting a 2 in front and making 2 groups of Al2O3 messes up your count over here. So this changes, so 2 times 2 is 4. We already balanced that. What am I going to do? All right. So this might happen to you, and you might have to come back and rebalance. Okay. So 2 ways to do this. You can multiply again, or you can erase and start over for this aluminum. Okay. So if I have 2 already, I need to multiply 2 times 2 to equal 4. All right, so that means I'll have to multiply this by 2 as well and make it a 4. Okay, what I prefer to do is start over because since aluminum is by itself, you have to ask yourself the total count I need for this is 4, right? So in order for that to happen, if I had a 2 there, that wouldn't work. So I need to change this total to a 4. So 4 times 1 is 4, which would give you the equal amount. So sometimes you have to go back and reset and start one of these symbols over again, and that's okay. So be comfortable with that. All right, going back and forth and back and forth. All right, so you have 1, 2, 3, 4, 5 to do on your own, 6 to do on your own. Try your best, and if you need help, reach out to me. I am available to help. If you set up you send me a Schoology message, I can hop in a Google Meet with you at some time and help you out. Or if we're in class, I can hop on with the class and try again. All right, so please be trying on this. This is due. This is a real assignment. It will be in your grade. Make sure you practice and get it done. When you are complete and you finish all of these questions, what I want you to do is you'll click this turn in button up here in the top corner. All right, turn in. This is the button you're going to click when you're all done. Okay, if you don't click this button, I don't see the assignment. Also, do not turn this assignment in unless you're all done. Don't do what I did down here, all right, and then peace out, because these ones will not count for as much as the ones you have to do on your own, because I gave you the answers to those ones, duh. So make sure you are doing the ones on your own. These are the ones I'm going to be grading. All right, if you don't do them, they will hurt your grade. Please just try. Please just try. All right, that's all I got. If you need help, reach out and I'll be glad to help you. I'll see you guys on Friday.